We don't need these. Not yet. Okay, chapter 11, 3D figures. And then 1.1 is 3D figures and cross sections. Cross sections mean we're just cutting it in half or we're cutting it in different ways. So those are cross sections. Vincent, you told me a cube, right? Is that the 3D shape you gave me? Pyramid? Okay, let's go with a cube for now. Who gave me a cube? Carson? Is that you? Okay, draw a cube. Oops. So a cube is made out of how many squares? 6 squares. So you have 6 squares. It's kind of like drawing a square and then pushing it back. So now we have a volume in that shape. So let's say how many sides? How many vertices? Let's do how many edges? So first one, how many sides? Carson said 6. Do we see all 6 sides of this cube? Yeah. Okay, vertices. Is that a new word for us? No? What does vertices mean? Another word for this is also points. Points. So 2 lines can meet up at this point right here. And this point. And this point. And this point. So there's 4, right? Okay, let's do some more. 1, 2, 3, 4. So that's how many points are in a cube, which is about 8, right? Got 8. Okay, last one. How many edges are in our little cube? So how many different lines do we have? Look at our shape. How many edges do we have? I'll give everyone a second to write, because we went a little fast. But I want you to count. And then show me with your fingers how many edges we have. Okay. No, you're telling me 21. Yeah. How many edges? 8. Camille, how many edges? Is it 10? Oh. Good job. Raylene, how many do you think there is? 5, 6, 7, 8? 8? Okay. Yeah. If only you could sign it in sign. 11. No. Face it towards you. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yeah, right? And you know what's so weird? This is American Sign Language, but if you do British Sign Language, they do the whole alphabet with 2 hands. And numbers with 2 hands. Like this is 1, this is 2. Like, just do 1. Why do you have to put another hand in there? So, edges should have been 12. 12. Yeah. So, let's do it in pink. So, like, this is an edge. It's kind of like connecting on the points. So, these are all edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, and we got the dotted ones, 10, 11, and 12. So we have a total of 12 edges in this shape. We're gonna make a table for a second. Make a table, make it across. This is gonna be types of prisms. Then we're gonna have faces, which is the same thing as sides, which we're just gonna say is F now, so faces. Then we're gonna have vertices, which is V. And our last one is gonna be edges, which would be E. So what type of prism was this? A cube, which is technically a square prism. And if it was elongated on the sides a little bit more, it would be a rectangular prism. And if it was a rectangle, well, all squares are rectangles, so it would be the same. So this is a rectangular prism. Now, Vincent gave us a pyramid before, right? So that, we're going to hold off on that one. I'm thinking. That's more like a pyramid shape. That's a rectangle pyramid. What if I did a rectangular prism? I would start with 2 triangles. And I'll extend it out like such. That is a rectangular prism. So rectangular. So we already did the rectangular. We're going to do the triangle in a second. But faces for this one was 6, 8, and 12. We already got that. Okay. Looking at the triangular prism, how many faces are in the triangular prism, which we drew over here? 5. Do we see all 5? 2 triangles and 3 rectangles. So we have 5. How about vertices? So how many points does it have? Show me with your fingers. In ASL numbers, do you remember what it is in ASL? Yo. That's 9. How many vertices? So how many points does it have? How many times do lines connect? You're saying 7, Carson. No, that was 8, so that's 9. That's 8. 6?
Oh.
It should be 6.
For some reason I was thinking of the rectangle.
No, it's okay. So here's 1, here's 2, here's 3. Then we just have straight lines. 1, 2, and 3. So 6. We have 6 vertices. How many edges do we have? How many times do they connect? Ashley, how many edges do we have? Yes, 9. We have 9 edges. Do we see all 9 edges? Okay, let's call that a day. We're just gonna do 2. I mean, we can do a third one, but I'm trying to think of a third shape. And 5-sided shape is a pentagon. Do you want to do a pentagon? No. How about we do a shortcut for the pentagon? Okay. So 5 to 6, right? That was plus 1. 6 to 8, how many did I increase? Plus 2. How many did I increase here? Oh. Yeah, but how many faces? We said was 9. That's my bad. 9. How many did we increase here again? 3. Plus 3. Okay. Next would be a pentagon. Let's call it pent. Yes. Pentagon. I will sketch this roughly out. Ooh. That's a hexagon. One. Okay. If I could draw that better, I would have. Boom. That's roughly. Whoa. How many faces does this guy have? So we got how many on the outside? We have one up top, one over here, 3, 4, 5, 6, 7. So this should be 7. Okay, so we went up by 1. How many vertices does this have? So how many points? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. So 10. So we went up by 2. How many edges does this have? 2, 3, 4, 5. How many does it have? 15. 15. Yep, 15. Plus 3. This pattern, this pattern keeps going on and on as you keep going up. For each additional face that we are getting with our prisms, the prism gains 2 vertices and 3 edges. This is called Euclid's theorem. Yeah. You just did Euclid's. So, I'm trying to remember Euclid's there. Euclid's formula, which you just discovered. So this is F for faces plus V equals our edges plus 2. Should I go over what each letter states, or do we know what F stands for? Faces. No, it's going to be plus 2. So let's say we take a face 5 plus 6, that's 11. And this is 9, so that's 9 plus 2 is 11. So faces, V is for vertices, and E is for edges. Now, this doesn't just apply to prisms. It also applies to other shapes. Do you guys want to do a funky pyramid? No? Well, too bad. We're doing a funky pyramid. How are pyramids and prisms different? Okay. Let's draw a basic pyramid, like so. That's a pyramid. Very roughly drawn one. This is a prism. What's different about these two, as they are very poorly sketched? They are different shapes. If I look at this one, this is a rectangle, right? Down below, this is also a rectangle. This one is, let's say, a square down below, but it meets up at one point, right? Up top. So that's the difference between a pyramid and a prism. A pyramid is going to meet at one top. You know, like Egyptian pyramids, they all meet at one top. Well, it doesn't matter what the base shape is, but they're all going to always meet up at one top. Crossing water. Let me get some water. Okay. So let's look at a funky one. We're going to draw this hopefully well. I want you to draw a hexagon at the bottom. Hexagon has how many sides? 6. So that's my hexagon. I'm going to meet all at a point up above. Yes, draw this. I could have drawn that better. Okay, I want you to figure out how many faces, how many vertices, and how many edges. Actually, how many hexagons do we have in this? In this shape, how many hexagons? 1 hexagon. Lily, how many other shapes do we have? 6 triangles. You're always going to have triangles in a pyramid. So we have 6 triangles. So, Drew, if I have 1 hexagon at the bottom and 6 triangles around the outside, how many faces do I have in total? 7. We have 7 faces. How many vertices do we have? So how many points? Ashley, how many vertices do we have? Yep, vertices, points, same word, kind of. 7. Now, edges might be a little difficult to see. That's why we can use this formula. If I have 7 faces and I have 7 vertices, then E must be equal to that if it's plus 2. So we can solve for this right now. So I have 14 equals E plus 2. Vincent, what can I do to get E all by itself? Minus 2, minus 2. So I have E equals 12. So if you couldn't see that you have 12 edges, we have 12 edges. A lot of 3D shapes have really funny names. So this is called a it's a long one. Hexagonal isopoly pyramid. The short name for that is a hippie. This is a hippie. A hexagon with 3 triangles that's a pyramid is called a hippie. A lot of them have weird names. You don't need to memorize the names. But this is called hippie. If you don't remember how many pentagons, okay, pentagon, then we have hexagons, then we have heptagons, then we have octagons, and then we have dectagons. Pretty sure that's not how you say it. These are the beginning of your words. Yeah. The edges are 12. Yep, we're going to use this formula to help us get it. We just want to find what each of them is. This formula can help us. If you couldn't visually see that there is 12 edges, this formula can help. Okay, if I say a pentagon, how many sides do I have? 5. Hexagon has how many sides? Heptagon, these are French words, by the way. 7. Octagon, 8. And dectagon, 10. Yep, these are French words. But these, if it says this in the beginning of them, then you know how many sides they are. This is a good recall to remember. Lovely. Okay. Want to do a problem up on the boards? Yes. Cool. Should I let you pick your groups? No, we should do a random generator. Yeah? Okay, I'm gonna have to switch the screen though. I'm gonna wait for two to wait. Okay, random.
What were these again this week? Like the faces or
Yeah, F is for faces, V is for vertices, so it's the points, and then E is for the edges. So how many edges on the shape? Oh my. Oh, those are like if I say hectagon, if you hear hect, then you know that's 6 sides. So it's a nice like shortcut. So Lily, Ashley, Camille. I keep forgetting it's with a K. How many times did I do that? Is it with a K or a C? C. Okay, never mind. I am right. Camille. Raylene. Drew. Carson. Coyote. Vincent. Okay. Let's do 3 groups. 1, 2, 3, 1, 2, 3, 1, 2. Okay, that's what it is. How many times? 2. That's 1. That's so loud. Okay. One more time, we'll go. Go to your groups. Okay, go to your groups. I'm gonna put a problem up on the board. A word problem, too. Yeah, you can erase everything.
try to.
I'll show you. It's called a botanic solid. It's the same shape 20 times, all put together. It's a lot of triangles. Mm-hmm.
Here's poppers.
You good, Drew? You limping?
Yeah.
From what? Okay, what did we get for the first one? 12. Yes, we should have done face plus V vertices equals E plus 2. How many edges do we have, Vincent? Okay, and what else did we know? Which is F of V. Faces. 20 plus V. So that should have been 20 plus V equals 32. And if I subtracted 20 from both sides, I should have V equals 12. V is 12. Do you wonder what this looks like? Yeah. So this is called a botanic solid, which is a very special shape. There's only 5 of these types of shapes in the universe. People have tried to find more. It is really hard. So we're going to skip this for a second. So I'm going to show you a platonic. So there's only so many out there. This is the one you just drew. This one down here. It has 20 different sides, all made out of triangles. So to make a platonic solid, it has to be the same shape every single time until it becomes one shape entirely. So this one has 1, 2, 3, 4 triangles. This one has 8 triangles. It has to be the same shape over and over and over again. So like a cube is one, but there's only 5 of them out there, and they look kind of cool. This is a good image to see. It's the same shape over and over again, put together at all of its edges. Can you form the same shape? And there's only been 5 out there in all existence. Cool. So you made that one, 20 sides. Cool. That's why I had to do for hyperfields. Use platonic solids. It's cool. They're cool. They don't seem cool, but like wait until they're cool. Okay, last one. You took a shape and you made cross sections. A lot of you guys took cubes and you made cross sections. When I cut this, let's say perpendicular to the base. I need a different color. So set a cube in your notebooks. If I take like a piece of paper, and I'm gonna cut it like so. So now I have that shape inside. What shape is that inside that we are now having? If I cut it in half and I open it up, what shape am I looking at? This is more of a rectangular prism. You drew a cube, that's fine. If I cut it perpendicular to the base, right in half, what shape is this right here in red? What is that shape? A square if it was a cube. Yep. And if this was a rectangle, which it kind of looks like in this one, it looks more like a rectangle. Okay. Let's look at a cone. What is my base in a cone? The top, right? It's a circle. So this is my base. Now let's cut it right down so it's even with this guy. So I'm gonna take like a sheet of paper and I'm gonna cut it down like so. Boom, like that. I make a shape inside. So this is kind of cut in half like this. It goes down to whatever this point is, and it goes down to here. So if I cut it perpendicular to the base, this would be like a 90-degree angle. What shape do you get for a cone? Yep, this is a triangle. All right there.
Oh, are we trying to solve like what the shape is of what's cut?
Yeah, so if I cut this in half and I split and give you 2 of them, what would be the shape that you're looking at right now? Yep, it would be a triangle. So it would look like something like that inside. Okay, sketch it in your notebooks. This is the cross section for a cone. Or you can do some harder ones. Okay, let's Drew, pick a word out of these. Oh, pick the hardest one. So a dectagonal, heptagonal. Okay, we're gonna draw a heptagonal prism. So we need to start with how many sided shape? We're talking about hept. 7. So 7 sides. Let's see if I can do that. 1, 2, 3, 4, 5, 6, 7. Okay, we're gonna go with that. Let's say that's the same shape. And then you draw another one up top. One, two, three, four, five, 6, 7. That's close to what I have. So draw the same shape you have from the bottom up top. And then connect the same points. Ooh. Okay. It's a little twisted. Raylene, why is this a prism and not a pyramid? It could have a hepta base too. It could. Kind of like this one had the hippie one had hexagon in the bottom, right? And it meets all of the faces meet where of the triangles? At one point. This one we're not meeting all at one point. We're meeting at the same shape up in the top. So not pyramid because not meeting at one point. Okay, Carson, take the shape and I want you to cut it perpendicular to the base. What is the base? Yep, so let's do B for base. B is a heptagon. So I want you to cut this perpendicular to the base. So parallel with the base. What shape would you get if you opened it up and looked at that cross section? A heptagon. Yep. So I would have a 7 side shape right inside there. And that would be my cross section for that guy. So that's parallel with base. We get a cross section of a heptagon. Now, Ashley, I don't always want to do it parallel to the base. What other way might I cut it? Yeah, this guy. How might I also cut it? If I don't want to go parallel to the base, I can also do what to the base? Yeah, perpendicular to the base, right? Let's choose a different color. Let's do green. Okay, perpendicular to the base. I'm going to cut this one, let's say right in half, up on the top. So now I'm going down. So if I go from here to here, I'm going to cut it all the way down. So it's parallel, not parallel, but perpendicular to the base. Yeah. Where? Here? Not pyramid because not meeting at one point. Yep. So if I'm perpendicular to the base, what shape do I get in my cross section? That's the hardest shape to do. Yeah, that's true. shape do you think we're gonna get? Yes. Would I know that? If I could pick any other shape, it'd probably be better. Yes, we should get a rectangle. Perpendicular with base cross section. We get a rectangle. I'm just start doing these short. We get a rectangle. Yeah. You're probably gonna have to draw the cross section and what shape it is. Like what's in red, you're gonna have to draw the red bit. I will give you the straw bit. Yeah. I mean, or it's gonna be a word problem, and I'm not gonna tell you. So, but it's probably gonna be given to you, the shape. Yep. Okay. Okay, what if I cut it? Okay, let's go to an easier shape for a second. Let's say I have what shape is that? Oh, I'm running out of room. Okay, backing that up. We're moving this over.
What does it say in the green?
Rectangle. We get rectangle. Okay, let's change this for a second. Vincent, what shape is that? Yeah, hexagon. We're gonna make it a pyramid for a moment. Because I can draw this so much nicer. Okay, we did it perpendicular to the base, and we did it parallel to the base. What if we cut it in neither one of those? So then, let's cut it like diagonally. So we start up here, like so. I'm gonna go down, kind of cutting it like this down to the top. So this is the top. I'm gonna cut it down. Then the back. So if I had this bottle, I'm gonna cut it this way at a diagonal slant. I'm not going perpendicular to the base, not doing it parallel anymore. I'm doing a slant, like so. When I did that, what shape would we get? Half of. So I'm gonna go this. I need like a shape, like a circle, a square, a rectangle, an oval, pentagon, hexagon. I need a shape. What was it? We have 6 sides, right? No, you're right. Hexagon. 6 sides. We have a hexagon. It's just going to be elongated, right? Yep. So we have a hexagon. Thank God for that. We have a elongated hexagon. Don't we love drawing these? Yeah, that's fine. Okay. Cross sections. They're fun. That's it. That's how you cross. You just have to identify what shape it is. When you. Yep, when it crosses through. So let's do one more. Draw a cylinder. Oh. Promise. Last one for cross sections. I have a cylinder. I'm going to cut this diagonally as well. Not perpendicular, not parallel to my base, but kind of diagonally. So it kind of goes down, out, and then up. What shape would I get if I cut this exact thing diagonally. A what? An oval. Yes. Do we all see where we get the oval looking shape? Wow, that was a bad oval. We should get an oval looking like that. Ashley, do you see the oval? Yep. If I cut this thing diagonally, I would get an oval, not a perfect circle. Because I'm going up and I'm going down. But it's a long cut through it. Okay. Cool. 3D shapes. That's intro to 3D shapes. We're going to do volume with 3D shapes in the future. Drew, do you see it? Okay. We have a cylinder, right? This is my card. This would be parallel with the base. This would be perpendicular to the base. If I did parallel, I'm cutting an exact circle, right? That's what a circle would be there. Okay, take this, and now I'm going to turn it kind of slightly. So it's going to be a stretched out kind of circle, because it's still an oval. So it's going to curve up top and then curve on the bottom. So
you could have one slanted.
yeah. So like it's not, this isn't flat, this is back, and this is forward. So this is kind of the back bit, and this is forward. So this should be like a fatter line, because it's forward. And that's the back line. So oval. Okay. Now we're just drawing 3D shapes. But how do we get a 3D shape? That's a question that we can talk about. We're going to talk about revolution. Revolving it around. I want you to give me a 2D shape. Any 2D shape. A cube? Yeah. Give me a 2D shape. A square. Okay. Everyone, give me X and Y axis. And put a square on your axis like so. Okay. Let's revolve it around the y-axis. So I want you to turn it around. So take your shape, your flat square, and I want you to flip it all the way around. Not flip as in the whole thing, but it's gonna revolve it around. You can make a 3D shape from it. Okay? So we can come inside your paper. I'm gonna go around, 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 around. Then I get about here. I've gone 180 degrees, and then I'm going to keep going, keep going, keep going, all the way back to the front. So I went out here, I went down, and I made that shape again on the other side. And I went around front. So I just made 2 circles from the top and the bottom. Down and down. Ooh, that was bad. Raylene, what shape is this? All of this together. What is this now 3D shape? So I have a circle up top, I got a circle in the bottom, and we have 2 sides. Cylinder, yeah. Cylinder. If I flip this around the x-axis, I would get the same thing. What shape would give me a cone? If I did a circle, I would get a very weird shape. Let's try a triangle. Like that. If I rotated this around the y-axis, like so, this would go back, 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 then come out and come in front. So it'd get a shape like that. And that's a downwards turned cone. Okay, before you leave, we have homework. Lovely homework. 10.1, page 473. We do 12, 13, 16, and then 17 to 24. 17 to 24, some of them are doing rotations. If you're having trouble with it, just try. If you don't get to it, it's okay. We'll talk about it in class. But definitely do all the ones before that as well. Cool? Yeah?